Good morning, students. So this is physics practical number 18 to determine the characteristics of a transistor. Now since transistor is not in our syllabus, so we'll only see the sufficient minimum knowledge required for performing this experiment. Right, so right now we are going to see how to join the connections of a transistor circuit, how to remember it easily. So first thing you should keep in mind that transistor is of two types. First is PNP, as you can see over here. Second is NPN. But for this practical, we are only going to use NPN, this one, and not this one. Therefore, we'll join the connections over here only. We are not going to use this one, right? So for this experiment, we are going to use an NPN transistor. This is the symbol of a transistor. Second thing, a transistor is a device which is having three terminals. First is emitter, base, and third is collector. So you can see this is E stands for emitter terminal, B stands for base, C stands for collector. So in the emitter you have two connections, for base you have two, and collector you have two connections, right? Now unlike the previous physics experiments that we have performed with only one single source battery, a transistor requires two power supplies. Therefore you have two knobs. Right, so inside the knobs there are batteries, there are power supply, there is a power supply, right? So over here also you have a battery inside of it, right? That is connected to the external circuit, external source, right? So this, if you observe carefully, this is written from 0 to 1 volt and this is from 0 to 10 volts. So the power supply which is having higher amount of volts becomes my output battery, and this is my input battery, right? So output supply and output supply. Correspondingly, now if you divide this circuit from the middle exactly into half, right? So this becomes my input voltmeter and input ammeter. This becomes my input circuit, and this is my output battery, output source. Therefore, this becomes my output circuit. So half of this is the input circuit and this is the output circuit, right? Now remember it. So we have, see, this is from 0 to 1 volt. Therefore, if you observe, this is also from 0.2, 0.4 till 1 volt. So this voltmeter is basically used for measuring voltage, the voltage which you are varying from this knob. Similarly, this is from 0 to 10 volts. Therefore, this voltmeter is also from 0 to 10 volts, right? Fine. Okay. So we now start connecting the circuit. So you know that a voltmeter is always connected in parallel to the supply, right? So we'll simply connect this voltmeter, the positive with the positive of my battery, the battery which is below this, right? So these are the connections for the battery. This is positive of this battery and this is negative of this battery. By the way, these two are similar, right? These two are internally connected. So they basically both are the same thing only, right? So I take a red wire from positive of my voltmeter to positive of my battery and negative of voltmeter to negative of battery. Also, the color of the wire has nothing to do with the connections, first point. Second point, I could have connected the positive over here as well. It doesn't make any difference. Why? Because internally these two are connected. I just told you. Similarly, the negative can also be connected over here and it won't make any difference, because these two positive and these two negative mean the same thing only, right? But for our convenience, we connect the voltmeter always across the terminals which are on the outside. So first voltmeter is connected. Fine. Now we connect, this is the input circuit, therefore input power supply, right? Now this is the output circuit, so we'll connect the voltmeter which is on the output circuit, right? So positive of my battery to positive of voltmeter, negative of battery to negative of voltmeter, right? So 2 voltmeters are now connected. Now I need to connect 2 ammeters, right? Now a transistor, be it NPN or PNP, whichever transistor you have, can be connected in 3 configurations. Always remember 3 configurations, right? These 3 configurations are common emitter, common base or common collector. For our practical, this practical, we are going to use NPN transistor in common emitter configuration. Common emitter configuration means emitter terminal is common to both input circuit as well as output circuit. So our emitter will be connected to both input as well as output, right? So I take a wire, right? This wire is going through the emitter of my NPN transistor. We'll connect it to the input circuit, input battery, right? Also, if you observe, this is the negative of my input battery, right? So emitter terminal is connected to negative of my input battery. Similarly, the second emitter terminal will again be connected to negative terminal of my output battery. So both the emitter terminals are connected to negative of input as well as negative of output. Fine. So both the terminals we have connected. Now we will have to connect base as well as collector, right? Now always remember this, all the terminals which come out of this transistor always go inside negative terminals. For example, the two from emitter went into negative of both batteries. Similarly, see, the collector is on the right hand side compared to the base. So collector will be connected in the output circuit and base will be connected in the input circuit, right? So I will connect the base with the negative of my emitter, right? I just told you that all the terminals from the transistor are always to be connected in the negative terminals, right? So base I have connected with the negative of my emitter, and similarly now the black wires are over, so I will have to use a red one. So collector will be connected to the negative of my output circuit, negative of my emitter, right? So base, this is base, negative of emitter, and collector, negative of my this emitter, right? Now only these two terminals are left, positive and positive. Since this is on the left hand side input circuit, therefore from positive input to input battery or input supply. Similarly, this is on the right hand side output, so positive of this to my positive battery. Right? So this completes our circuit connection. Fine. Okay. Now always remember, whenever we have NPN transistor connected in common emitter configuration, the current through this emitter is always in microamperes. You will never get a current in milliampere. For this entire practical, all the measurements are in microampere, right? You see only this meter has these two, micro and milli. All the other meters have single variables, volt, milliamperes and volt. So this has two options. So out of the two options, we are always going to use microampere only. Therefore, this little switch you can see should always be in the upside direction. Upside means 250 microamperes, means we are measuring current in microamperes, right? Also, see, this is measuring voltage across the emitter and base collector of the transistor. Right? Can you see it? Yes. Therefore, we call this VBE, means voltage measured across the base and emitter. Right? Therefore, we call this VBE. VBE. Because this measures the voltage across base and emitter. Similarly, this voltage measures the voltage across collector and emitter. Although this is not very obvious from this circuit, but you can see it from your circuit diagram that is there in your lab manual, that this voltage measures the voltage across C and E, collector and emitter junction. Therefore, we call this VCE. Similarly, this emitter, where is this connected? This is connected to the base of the transistor. Therefore, this measures base current. We will call it IB. Fine. Now this emitter is connected to the collector C, collector of my transistor C. Therefore, this will measure collector current IC. Right. So now we can start performing the experiment. You can turn on the switch. Make sure before that, as a precaution, this should always be in the upside, means 250 microamperes. All the connections should be fine. the knobs should be completely closed, 0 0. Right? Now you turn on the circuit. Okay, so the light is lit. Alright, so first table, there are three tables for this experiment. The first table is of input characteristics. Input characteristics means now this part is my input circuit. So in input characteristics, you need to change this voltage and measure this current for constant value of this voltage, right? So in your table, it is mentioned for constant values of VCE, you change VBE and measure corresponding values of IB, right? So for example, in the beginning, if I fix this to, let's say 1 volt, right? So I can turn this knob and I'm fixing this to 1 volt. Yes. Okay, so this is fixed at 1 volt, right? Now I will change this voltage by using this knob and measure corresponding deflection in current. So if I move this, you can say this is same at 1 volt only, right? This is moving, right? Till 0.4 no deflection, but suddenly I'm rotating this. Suddenly after 0.5 and 0.6 you can see a deflection in this meter, right? This is fixed only at 1 volt, right? So by changing the values of V, you can measure different values of IB. And make sure this never goes out of range, right? You need not measure values of this, but always as a precaution, make sure that none of the meters move out, the needle in none of the meters move out of deflection, otherwise it will damage the meters, right? So you change this voltage and you measure different values of IB for fixed values of this, right? So that will complete one of the first column of your first table. Now for the second column of the first table, you need to choose a different values of this, a different value for VCE. So initially we had set this for 1 volt. Now we'll set this to, for example, 2 volt, right? So we'll fix this at 2 volt. Now again we will change this by using this knob and measure corresponding deflection over here, right? So I'm changing voltage. If I'm changing voltage, right, I will see a deflection in current. So you can see again after 0.6 or 0.5, this starts showing some deflection. This is fixed at 2 only. If this gets disturbed midway while taking the observations, you again bring this back to 2 volts. Okay, so that will complete your second column of the first table. Now for the third column, similarly you set this to 3 volts and 4 volts, right? And that will complete your 4 columns and your first table will be complete, right? So that will give you input characteristics of your transistor. For the second table, you need to complete the table for output characteristics. Now in output characteristics, these 2 meters are in my output circuit. So you change this voltage and measure corresponding deflection over here. Measure current, this is I, what is this? IE, no, IC, collector current, right? So in the output characteristics, which is our second table, we change the voltage and measure corresponding change in current for fixed values of this meter, not this. For the first case, what we had for the first table, we were changing voltage, measuring current for fixed values of voltage over here. But for the second table, for the output characteristics, you are changing voltage, measuring this for fixed values of this current, right? So we will fix IB, we will change VCE and measure corresponding changes in IC, right? So for the first column, let us say that we fix IB at, for example, 50 microamperes. This is very sensitive. This IB is very sensitive. So we have fixed this to 50 microamperes. Right now I will change this and measure corresponding changes in IC. So I'm changing VCE. Now you notice that as soon as I change VCE, this has also moved, right? So again, I'm bringing this back to 50 microamperes. Okay, 50 microamperes, right? Now you move the voltage, this VCE, and measure corresponding changes in over here, IC, right? So every time you move this will also move a little bit. So therefore you need to use both of your hands, right? Make sure this always stays at the fixed value 50 microamperes, right? Now you change the voltage and you measure the corresponding changes in current over here. right? This doesn't show much deflection. It becomes constant after a particular value, right? Okay. So that is the first column of the second table. Now for the second column, you need to choose a different value other than 50 microamperes. So for the second column, let us choose 100 microamperes, right? So IB is fixed at 100 microamperes. Again, you change voltage and this is moved, right? So 100, again 100, right? Now you change voltage, this, and measure corresponding values over here, right? So again, this will become fixed, almost fixed after a certain value. All right. Now similarly for the third and the fourth column of table 2, you can fix this IB to 150, change this VCE and measure IC. Similarly for the fourth column, you can change this to 200, right? Change this and measure this, right? For the third column, you need to change this IB and measure IC. Third column is used for finding the current gain, right? Therefore, you change the input current and measure the output current. Fine, you change the input current, measure the output current for fixed values of this voltage, right? So let us say initially I fix this to 4 volt, right? So this is fixed to 4 volt. Now you change the input current, that is IB. You will see a deflection in IC as well. You need not bother about this, right? So see, I'm changing this input volt current and I'm seeing a deflection in the output current. So for different values of IB, you will get different values of VC. Again, keep in mind, IB is always in microamperes. You only observe the upper scale, 0, 50, 100, and not this 0, 10, 20. That is for milliamperes, right? Milliamperes we don't have for NPN transistor, right? So for the second column of the third table, what you do? For the second column of the third table, you can choose some other value of VCE. So in the first column, I had chosen 4. So for the second column, I can choose it to be 5, right? So 5, again, you will change this and measure this, right? This will move. So midway, you will again bring it back to 5. Every time you should bring this back to 5, change this, measure, change this and measure this, right? Similarly for the third column, you can keep this fixed at 6. For the fourth column, you can keep it fixed at 7, change IB and measure IC, right? That will finish your 3 tables, and after that you can do calculations and plot the corresponding graphs. Thank you.